Jeff. All right. Thank you very much for the lovely introduction. So today we're going to be speaking about, can everyone hear me? Okay. So today we're going to be speaking about just mass reproducibility and replicability, primarily within economics, but also a little bit more in political science and just a touch in psychology. So this is joint work with many co-authors. So this is a consortium effort. So right now, I think we have over 300 amazing co-authors, the primary ones being the first 5. So Abel Berdur, who's the director of the Institute for Replication, Nikolai Cook, who's been working with Abel and I on this initiative for a couple of years, as well as Juan Aparicio and Lenka Fiala. And so a lot of this work comes from all these researchers which we've been coordinating to produce reports for us, which we then input into a data set and then continue to analyze. We've been working with many of these researchers since 2022. We've coordinated hundreds of teams, over 40 events across 4 continents in econ, poli-sci, and the social sciences. And there was one person here today who I couldn't place until someone said Bergen, and then I realized exactly then that I met them at Bergen. So we've been everywhere. And this, in particular today, we're going to be talking about 248 reports, which have contributed 1,600 new robustness checks. Fortunately for me, there's been a lot of overlapping discussions about key criteria and key definitions, which I'll be using constantly. But just to remind everyone, when we're talking about computational reproducibility, kind of coding discrepancies, which you think of as coding errors, as well as robustness reproducibility, or just robustness checks or sensitivity analyses. So computational reproducibility is kind of the bare bones. If you give us your data, you give us your code, we run it, and the results that you produced in your published paper, in fact, matches what you gave us. So that's computational reproducibility. Coding discrepancies, coding errors, just something you say you do in your paper, but you're not necessarily doing in your code or within your data. And then robustness reproducibility, we're going to take your data and change the procedures, methods, maybe operationalization of, say, key variables and see if the results still hold with those ideas. And so what we've been doing over the past couple of years is producing these rates. And so what we're finding within primarily economics, we have 91% computational reproducibility. About half of the papers contain some type of coding discrepancy. These could range from relatively minor to relatively major, and about 75% robustness rates across the original results. And that's supposing the original result was statistically significant at the 5% level. So you modify the methods or the procedures a bit, and you approximately get the same, statistical significance level as before. Now, we did this last year. The paper actually came out in Nature a couple of weeks ago. Kevin pointed that out, and I think you had the front cover of the journal on one of your slides. But what we're doing today is we're going to do this by methods. And so previously, we didn't have the amount of observations in order to look at specific methods. I used to have subject to change, and Abel kindly reminded me that everything's subject to change. But this is as new as we can get it. And in general, what we're seeing is difference in difference, instrumental variables, and RDD, which I'm going to say are roughly observational methods, are just a little bit worse than RCTs. So if you're either using a randomization or collecting your own data, we're typically seeing higher robustness rates. We have done this by fields, and I'll point out a few towards the end. These are non-mutually exclusive, and these are JEL codes within economics. So you publish a paper, you might have 3 different types of JEL codes, but we are looking at JEL codes and how they correspond. And so just to reiterate why this matters is that replication is really fundamental to science. So being able to observe something multiple times in independent trials is how we try and build up our ideas of generalizability, highly replicable research. Now, reproducibility, which is primarily what we're doing, is not replication. Although we're the Institute for Replication, this is a very poor term. We're maybe closer to the Institute for Reproduction. But reproducibility really, you can think of as necessary for even considering a replication. If you give me your data and your codes and I can't reproduce it, why would I ever invest in a replication? Right? Like I don't have the faith in perhaps I do not have the faith in your research from what you've given me that I should even pursue a replication. And again, what we're trying to do at I4R, and by reaching such a broad audience, is promote and improve the norms surrounding reproduction and replication in science. So just increasing visibility, increasing the incentives to do it, publishing neutral tone reports which are both positive and negative, right? So we're not just going to publish the reports which are, damning some original research. We're going to publish the ones which say, this is really, really good, right? This is robust, the code was clean, the data was excellent, we love this. And we're building a community, right? I think we sent out an email a couple weeks ago, and we've since generated maybe 300 researchers interested in working with us over the next 4 weeks. So it's been really valuable to see that develop over time. And again, what we're doing, we're providing evidence on the published research in the social sciences, just general robustness variation across methods, disciplines, fields, et cetera, and trying to understand how we can correct some of these processes with reproductions and replication. So the rest of the talk is just going to be going through the nuts and bolts of how we actually get this data. That's really how the sausage is made, and a lot of these numbers come from that. And as you'll see, there are some caveats, as there are with many aspects of research. I guess you can't ask clarifying questions. I forgot about that. I guess that's the normal economist in me, just expecting someone to raise their hand and say something. But yeah, I guess we'll hold those to the end. Some general summary stats, and then we're going to talk about P curves and T curves, primarily T curves. I guess for Stefan, this will help introduce your paper coming up next. But essentially what we're going to show you is that there are these kind of missing humps where we would expect results to be if you were to perform robustness checks. And last but not least, we pre-registered some ideas on the social sciences prediction platforms to try and understand if economists themselves and experts themselves can actually predict some of the results which we found. And in general, they might be off in level, but they're kind of correct ordinally, right? So they can predict which method is better, which field is better. Okay, so what we do is we host these replication games. So we coordinate researchers within an institution and try and get them to reproduce a paper and perform robustness checks on that paper. So the researchers will be 3 to 6 people with similar interests, usually grad students, faculty, staff, professionals. If there's people, professionals in the community, so say you worked at the Bank of Canada or the Bank of England or the Federal Reserve, you'd be more than welcome to attend one of these events. So we put you on a team of people with like-minded coding abilities, like-minded fields. So if you work in labor, we'll try and put you with labor economists. We'll assign you to a study. You'll read that study. You'll look at the replication folder. And the day of the events, you will try and reproduce everything and then come up with robustness checks with you and your colleagues. At the end of all that, you'll give us a report. We'll do that for other possible ways of being recruited as well. So the procedure is quite similar. You wouldn't have the same structured 3 weeks before you get assigned to a team. But the ultimate goal is the same thing, is to produce this report which checks computational reproducibility, coding discrepancies, and performs robustness checks, right? So can we reproduce everything? Is everything you said you did what you did? And if we perform some robustness checks, are the results still consistent, or at least roughly consistent, or reasonably consistent? We tell replicators beforehand, like there are some rules around what we're doing. This isn't just complete chaos, but please don't reproduce things which you know the original authors. We would appreciate if you let us know beforehand if any papers would not be suitable for you to reproduce. We don't tell them that we want things to be good or be bad. We just say, here's a replication folder. Please find if it's computationally reproducible, there's coding discrepancies, check some robustness checks. Teams choose how to reproduce and replicate. And so this is slightly different than how you might be doing it with R2E, with Yori and Peters. I think this is slightly different than the social science reproducibility platform, where there's a bit more structure in how you might perform robustness checks, a bit more structure in how you would input those robustness checks. This is a bit more up to you. Right? You do what you think is most appropriate. And this is really flexible for problems with coding errors. Right? So if there's a major coding error in your folder and we find that, we still want you to do robustness checks, but they're usually going to center around this coding error. Right? So that's quite nice. And then last but not least, at the end of it all, we'll edit it. I will look at your paper. I will look at the tone of your paper. I'll make sure that it's cordial and professional, it's neutral, and then we'll share it with the original authors. right? The original authors at the time might say, hey, I like what you did, I didn't like what you do, so be it. But they may come back and say to the replicators, so the team that we coordinated, what you did was nonsense, right? Like, you should never have done this robustness check, and the replicators could say, you're right? We didn't think about that, that was completely inappropriate, and then get rid of it. So this is just generally what's going on with the structure and how we generate these reports. So again, 248 with at least computational reproduction or robustness checks, and we have 1,600 new point estimates or things which we could compare, which I'll call robustness checks or reanalyses, and they usually come in these flavors. We asked that the teams of researchers to try and isolate one of these, but in some circumstances they might have multiple. So if there's a coding error, you almost always have correcting the coding error plus a robustness check. And just correcting the coding error to what the paper said is sometimes the robustness check in itself. At this point, you should all have been acutely aware of the sample selection which we're dealing with, right? This is very challenging in order to get off the ground, and we have to make some very drastic assumptions in what's going on in order to have anything reproduced, right? We look at journals which have had data editors and enforce policies, right? If we don't have code, we're in trouble. If we don't have data, we can't do this. So it needs to be accessible. The replicators select papers which are of interest to them. I provide them a list of 3 to 6 papers, let's say, and they don't know where it's coming from, but I provide them a list, and then they pick a paper. Sometimes you can't test statistics or coefficients, right? So if you could consider heterogeneity analyses or subsample analyses. There's no reason why you could ever compare that coefficient to the original idea. We're looking primarily at main claims of papers, mainly studies since 2022. Again, similar to we omit some test statistics, we somewhat adjudicate robustness checks. Some things just aren't fair. Fixed effects or hierarchical models are really subject to debate. So if you drop a whole bunch of fixed effects, there's no reason why that would be a reasonable robustness check, right? If this is important for their identifying assumptions, you can't just drop fixed effects. So we would say, you know what, we can't ever use that. And last but not least, there's potential for revisions, as I mentioned before. Most of these statistics I've already gone over, so the reproducibility rate, coding errors, proportion of studies without any robustness checks, it's about 15. The number of test statistics per report has a long right tail, so some have many, many, many robustness checks. If you think about a coding error plus changing, the sample, if you interact those two, now you're at 4. Right, so you can very quickly get many, many, many robustness checks. But yeah, a lot of the papers are coming from top 5 in economics journals, other economics journals, 80% plus minus. We collected this data to try and give you a flavor of what replication folders actually look like. So I say that our sample is quite selected, and this is one of the major reasons why. Right? So raw data cannot be provided in a whole bunch of circumstances. I think you had a really good slide on it, which it was ethics, intellectual property, and maybe something else. But there are constraints to providing raw data. So we expect that 40% can't provide raw data. That being said, cleaning and analysis code is a bit interesting insofar as 29% of studies don't provide cleaning code. Right, so you can't actually see how the sausage is made in some of these papers. You just have to accept that they'll show you how to produce the output, but not how to maybe cut your sample or define your variables. But naturally, this leads to reproduction rates which are less than 100, and in many cases for the reproducible from raw data, quite low, 40%, 44%. We're still trying to unpack the coding discrepancies, but for the most part, these can range from kind of major coding errors, so many duplicates are found, not cleaning raw data, not fully interacting coefficients or reporting the wrong coefficient as outputs, maybe not specifying a function or not having the numerical optimization program even converge to some solution, right? So there are issues, but we are not including transcription errors, right? So this is not you fat-fingered a 4 into a 5, right? This is not a pathway change in order for it to run on your machine. These are more substantive than just getting something to work, or it's much more generous than 1 of 200 of your coefficients was rounded incorrectly, right? These are a little bit more than that, but not necessarily huge, huge, huge changes in the number of observations. Okay, so now what we're going to do is we're going to look at some t-curves. And so this is where it kind of gets a little bit more fun and we have a bit more visuals. And so essentially what we're showing you on the left in the following t-curves would be the statistics, the t-statistics from the original published material. And on the right, we're going to show you the reanalyses of those statistics when our replicators choose robustness checks, right? So on the left-hand side, what I'm showing you is a t-statistic, so a coefficient divided by a standard error. And the right-hand side is the reanalysis of those statistics. And if you're familiar with Abel-Brodeur's work from earlier, what you should be anticipating is filling in this gap left of statistically significant thresholds. So just left of the 10% threshold, there's a lack of density. And when our replicators try and do robustness checks, they fill in this gap. And we're going to see this as we're going to return to this result multiple times. Unsurprisingly, p-curves have this same kind of pattern. So your statistically significant original result turns into much less likely to be statistically significant in the p-curves. So for anyone else, essentially we were shifting the density towards the right. So under a true null hypothesis, this p-curve should be uniform. When we look at the results, we take the original to the new coefficients, so the ratio. So if the old coefficient divided by the new coefficient are approximately the same, they should be 1. Right? So the magnitude of the coefficient should be approximately the same. And we see this is roughly the case. And so changes in our t-stats might be coming from our standard errors. We haven't really unpacked that as much as we possibly could do. But we're seeing similar patterns across a couple of other splits. And now we're going to move into different methods. And so with randomized control trials, we still see this general pattern of a lack of density before statistically significant results, and then it being filled in with our replicators, right? So you have that data, you have their code, you change some of the methods or maybe a sample slightly, and we see that the results are much less likely to be statistically significant, or at least it's moving a little bit, or there's more density left of statistically significant thresholds. This is even more true with indifference and differences. So you see, you take a DID model, you change the sample, rerun it, we have a lot more left of the statistically significant thresholds, and even more so with instrumental variables. So with the social science prediction platform, we kind of asked them, what do you think of these methods? What do you think the robustness rate of these methods will be? And ordinarily, you get that. So RCTs seem to be the highest, difference and difference somewhere in the middle, and then IV at the very bottom. We do this with JEL codes. These are overlapping, so they're not mutually exclusive like the previous categories. But you do see similar kind of ideas that if you talk to people within economics, you might understand. But development, you see a lot of filling in general. Labor looks okay. Looks okay. And then economic history has a lot of mass filled in, and we don't even fill in the mass close to 0. And then going back to by field, what we're seeing is a similar idea where micro and labor towards the highest, development somewhere in the middle, and then economic history towards the bottom. I've talked to Abel about this quite a bit, and it's really hard to disentangle these effects, where you might have RCTs within development, you might have RCTs within labor, and so it's hard to say exactly what's going on. And then economic history, you might have a lot of instrumental variables. So there is this correlation between the fields and the methods. last but not least, so this is the distribution. So in green is the distribution of our social science prediction platforms. So they're given a scale between 0 to 1 or 100 on what they think will be the robustness rate. That's the diamond on the right. And then that's the circle in the middle. And then the diamond on the right is what we see, right? So this is after we've performed all these robustness checks. That's what we see on the right, the diamond. And so we see that in general, the social science prediction platform researchers are underestimating how robust it is, but they are still kind of getting the order correct, right? Where labor is pretty high, dev is in the middle, and then history is at the bottom. IO is just in there because that's the snippet of my figure. But you could do this for all of the JEL codes if you'd like. Yeah. So I guess to conclude, this idea that left of a statistically significant threshold, so the 10% t-stat corresponding value, there is perhaps lots of p-hacking, but it's not tremendous. Even when we fill in a lot of the density left of that, we're not completely correcting everything. And is it like the worst thing in the world? Like, probably not. We're finding a lot of positive impacts of the discipline. So when we talk to people and we say, like, what do you think? I think a lot of early career researchers are surprised with the quality of the code. They're surprised that everything runs, and they're really happy that it's generally robust. Yeah. So that's all for right now, but I'm happy to hear your comments and thoughts and ideas.
Thank you so much for your presentation. I work at JPA where I've been doing replications for a few years, and I think we've had kind of similar findings, but basically whenever I get a package from a researcher that I need to double check that I need to run a computational reproduction of it, a lot of the time the errors I find are really simple coding errors where like an RA has flipped the exporting columns or something like that, like a column is supposed to be A, but it's actually B. So it's kind of, but all of the more advanced things are correct. It's just kind of like a very basic 101 issue. And so I'm curious on I4R's perspective on like, it seems actually your conclusion is kind of optimistic, but I'm curious if you have any kind of like perspective on how can we address, like we're doing so much advanced analysis in economics, but how can we reduce these like really basic 101 issues?
It's a good question. I mean, just for clarification, if they flipped the column and it was very clear, I'd be okay with that, especially if you could track it in the paper. But if you couldn't, I'd be a little more upset. How do you address sorry?
No, just to clarify. So like they were ready to publish that paper as it was. And so isn't that concerning that it's just such a small error, but then we have a published paper that shows like completely different results from just like a exporting error?
Yeah, I mean, it happens. Like, I think we're all human and we'll make those mistakes. I think at I4R we're trying not to penalize them. And at the very least, like if you correct the record by saying, you know, the dependent variable in this column 2 and column 3 are actually switched and it should be interpreted differently. But it does have big implications, right? Like if this is a major finding for their research and all of a sudden, you know, the coefficient magnitude is positive instead of negative and statistically significant instead of not, yeah, this matters substantially. I don't know what the solution is. Like, I think I'm not even old, but you know, when I did my PhD, using SDOUT and having perfect tables was a skill that not everyone had, and I'm not sure economists are the ones who have those skills to make like perfect end-to-end type replications and reproductions. But yeah, definitely having a perfectly set up Docker environment in a standardized manner, or even a Jupyter notebook where you can track almost everything just in line. I think there are solutions, but it's hard to try and find one which is universally applicable and not costly enough for people to actually adopt it. Yeah, thank you. There's a question here. Please.
Thank you. Just a clarification question about the things that replicators do. They also replicate all the tests that are included in the appendix of the paper?
So we ask them to do what they can, right? I think for those unfamiliar with economics, you can have sprawling appendices. So if you don't reproduce 75 out of 75 tables and check, that number of tables times the coefficients and standard errors and p-values within those tables, yeah, that's not necessarily feasible.
Got it. So part of those...
We ask them to do main results. So typically try and stay to table 2, 3, 4, figures 2, 3, 4, 1, 2, 3, 4. Try and focus on paper or exhibits which appear in the main manuscript and the public that's published. If you have time, please try and go towards the appendix.
Got it. My question was directed to, is it possible that many of those null results that you are filling out like near the bunching threshold are actually in the appendix and just the author didn't consider them as relevant for the narrative of the paper? So
we do try and guide them and tell them, do not do robustness checks which have been reported. So while we don't ask them to check the computational reproducibility of every coefficient in an appendix, we ask them to say, or to not do robustness checks which have been done.
Okay. So mostly are new.
That's how we interpret it. I don't have any recollection of original authors saying to us that robustness check was already done. This is not a contribution type of argument, but I'm sure there's been overlap at some point.
Thank you.
Yeah. Please.
I feel bad because I'm always asking the questions, but I loved the conference. Have you maybe seen differences if the studies were pre-registered when it comes to sort of these things? And maybe a second question, there are now a few journals that implement reproducibility officers, the way they call them, so that they guarantee computation reproducibility on papers. Have you ever taken those as a sample? Because you don't really need to do, in theory, the first part, because it's been done, so you just do the robustness checks.
So, okay, what was the first question? Because I haven't answered the second, but now I've forgotten the first.
The first one is, have you looked at the studies that have been pre-registered so that they had a protocol and statistical analysis plan with possibly details of the data cleaning before the data collection occurred?
I don't think we've done any formal analysis. We're reproducing papers in Nature, Human Behavior, and Psychological Science, which are much more likely to have pre-analysis plans and pre-registration. So I suspect that avenue will come out of those journals. But within economics, I'm not sure how strong the pre-registrations are compared to a pre-analysis plan. Like I couldn't tell you what that analysis would look like with our data, and I don't believe we've coded that. For the second question, which is, what about journals which implement reproducible checks before it gets published? I'm pretty sure all of these journals which we use, so we use the AEAs. So the AEAs have reproducibility checks by master students. So like this is 91% after it's been checked by people already. Papers from the QJE and JPE, I'm pretty sure do not have those. But then within the political science journals we have, I believe it's 2 out of 3 have checks. I think it's either APSR or AJPS, which do not have, only one of those, which do not have someone checking beforehand. So this is 91% after someone has checked most of these. And like this is after, like coding discrepancies after it's been checked by people and the original authors.